Hi everyone, my name is Nikunj Bajaj, and today we are going to talk about machine learning models in production, which we all know is a lot more than data scientists building machine learning models and us getting the big wins. This happens because building ML models involves complex interaction across multiple stakeholders, where the process starts by the business user providing the modeling requirements to the data scientist, who then builds the model and works with the machine learning engineer to implement the server code, manage the package dependencies, etc. The ML engineers in turn then work with the DevOps people to allocate the right set of infrastructure. Again, the data scientist has to come up with the metrics that they want to monitor for the model, and then ML engineer would instrument those metrics and work with the DevOps people to have those metrics and dashboards deployed. All of this happens where you have to continuously keep getting the feedback from the business user, which is typically very hard if the model resides completely in the machine of a data scientist. To solve this problem, a lot of large companies have automated a lot of redundant tasks of this process while allowing the data scientists to focus on the creative tasks and be more productive. We decided to build a similar system for every single data scientist in the world. If you're working with our system Service Foundry, we generate a lot of the API code, the documentation, we take care of the complete dependency management model deployment, and we also generate business user facing dashboards, your metric monitoring, and machine learning observability systems. All of these happen while the data scientist does not have to leave the comfort of their Jupyter notebook. To see the demo of our platform, we are going to use a common machine learning task, which is classification of the iris flower across three classes based on some of the features of its lengths and widths of the flowers. So let's jump right into the code. As a data scientist, you would anyways be writing this code to build the model that you have built. Now, if you want to use our system, all you would do is you would register the model that you have just built with a simple API that we have provided and provide the model a unique name. After that, if you want to use our machine learning observability systems as well, you log the data that you have in our system so that we can generate the machine learning modeling graphs for you. So here you would pass the X data, the Y data, and the predictions that your model has just made, and just label it that this is the training data that you are providing. Similarly, if you want, you can log your testing data as well, and you see that now the data has been logged. After that, you can go ahead and build your inference script just like you would typically, except you would also decorate the function with a simple API that we have provided and give it the route of the API right here from the Jupyter notebook. So for example, if this is the route that you provide, after that, your system is completely ready to be deployed. You just provide the name of the inference file that has just been generated here, and you will see that our system is automatically able to parse your local dependencies, is able to generate your API code, provides you a Swagger endpoint that can be used by your developers. It provides you an endpoint which is a deployed model, again, that can be used by your backend engineers to integrate your model with the product. You have your system monitoring dashboard, business user facing dashboards, and ML observability systems as well. So let's go do a deep dive into the stuff that has been automatically generated. So here's your Swagger dashboard where you have the documentation that you as a data scientist have written, and this dashboard is automatically generated. This is the endpoint where if the ML engineer passes the data, they will get the response of the model, that is what class is the particular flower. Again, you have the business user facing dashboard. This is a very minimal dashboard that we have for the beginning, but we will keep adding more metrics to it. So for example, the business user can change different types of data and submit this. This will internally call the model and tell you that, okay, this is the predicted class of the iris flower, and this was the latency of the system. You have all your system level monitoring, where how many times has your model been invoked, what are the errors that you are seeing, what is the latency overall graphs that you are seeing. All of that is generated right here. And besides that, you have the machine learning observability. And in this case, you can see that we are tracking F1 score, and you can always see that the training data accuracy is generally higher than the test data accuracy. So you pretty much know that the model is overfitting just by simply looking at this graph. Again, you have stuff like confusion matrix generated for you, and you can also see whether your feature set has been drifting since the time that you trained the model till the time that you're doing the predictions on top of this model. So all of those information is automatically generated, and then your overall workflow becomes a lot simpler. That is, you get the requirement from the business user, you're able to build the model, and the demo is generated very quickly that you can get the feedback from the business user. At the same time, a lot of the infrastructure code for the monitoring dashboards and the machine learning model itself is generated, and you can get feedback from your DevOps people, which is a quick stamp that they can provide if everything works. Similarly, your ML engineer can quickly review all the monitoring metrics that you have, and they can keep adding more metrics if they want to, for example, monitoring the CPU and memory usage of the machine if they wanted to. Thank you so much for listening, and if you have any questions, please feel free to reach out to us at nikunj@entire.co. Thank you so much.